looking to find our absolute extrema for this function. As we do so, of course, we need to figure out where the critical points are for this equation, which means finding the derivative, which is cosine of x minus sine of x. And we need to look to see where does this derivative equal 0 and where does it not exist. Well, we can rule out that second part right now because cosine and sine both exist for all real numbers. And so we can go ahead and say that there's no place where it will not exist. But there may be some places where it equals 0. So I set the whole thing equal to 0 there. I'm now going to solve this out. I think I'm going to move the sine to the other side. I'm going to add sine x to both sides. So then I have sine x equals cosine x. So the solution to this would be any points where sine equals cosine, which, if you remember your unit circle, is going to make this a lot easier. Because in the first revolution of the unit circle, we're going to have a point where sine and cosine equal each other here at pi over 4, and here, where they're both a negative, at 5 pi over 4. And of course, it would keep going around and around on that, but we don't need to really worry about all of the other coterminal angles because you'll notice we're given a set interval. It's only between 0 and pi over 3. So that tells us that, well, I don't need to worry about the 5 pi over 4, so I can just worry about that part. And so there's only one place where we actually get sine x equaling cosine x on this particular interval, and that's going to be at pi over 4. And so I now know which numbers I need to check when I'm looking for my absolute extrema. So the first one, I'm going to have to figure out what f of pi over 4 is. Any critical points, I need to check them. There's only one in this case, but if there were two, I'd have to check both. If there were three, I'd have to check all three, and so on. Then I also need to check the endpoints. So I need to check f of 0, and I need to check f of pi over 3 and see what each of those values is. So I'm going to take each of those and I'm going to plug them back in here to the original equation. And if we just go with our unit circle values, we come up with those. But since we are going to be comparing them, let's go ahead and break those all down into decimals. And so then we can look at these numbers and be able to tell where is the maximum and where is the minimum. So let's start with the minimum. I'm looking for the smallest y value from among these, and that happens at 0. So my minimum is going to be at 0, 1. And my maximum, again, I'm looking at my y values to see where it reaches the highest y value. And I can see that that's in the last one. That's going to be at the pi over 3. So that happens at pi over 3 and 2.732, or root 3 over 2 plus a half.